Hi, welcome back. Hononegah Honors Algebra 2. We're now going to dive off into something else here. We're going to talk about using what's known as trig identities. And recall that when an angle measure in standard position is the terminal side. So we're going to do a terminal side question similar to what we have done previously. So this was actually a question that comes up a little bit before, but it leads us into some more topics here. So remember when on a unit circle, cosine x, sine is y. Well, what if the radius then, because remember the radius of a unit circle is 1, that would mean by Pythagorean theorem, x squared plus y squared equals 1, which now converting that into cosine and sine, cosine squared plus sine squared equals 1. This is referred to as a Pythagorean trig identity. And it's one of many trig identities that you will have to know next year, more so than now. So remember, this is a lead in to things that you're going to do next school year. So trig identities. So the equation cosine theta or cosine squared x plus sine squared x equals 1 is a true for any value of theta. The trigonometric equation that is true for all values is known as a trig identity. And again, there is a whole page of trig identities that we will be using. Here it is. And so I would pause right now. I'd write all these down. These are all the trig identities. And if we were in class, we would actually do a quiz or a test. It's a mini, like just a short one that you would have to do all of these. So I'm going to go through this real quick. But again, you need to probably write all these down. First are what's known as the reciprocal identities. So cosecant is 1 over sine, and we used that when we did our graphing. And secant is 1 over cosine, and cotangent is 1 over tangent. So again, these are the reciprocal identities. Tangent and cotangent. Tangent is sine over cosine, and cotangent is cosine over sine. And again, we used that when we did our graphing, the underlying curve. Now for what's known as the Pythagorean identities. Sine squared plus cosine squared equals 1. 1 plus tangent squared equals secant squared, and 1 plus cotangent squared equals cosecant squared. Now, you can manipulate this too. So if I wanted to change this into tangent squared minus secant squared, or I do usually do it the other way around, sorry. Secant squared minus tangent squared would equal 1. Or cosecant squared minus cotangent squared would equal 1. So again, you can take this and manipulate it into any which way that you want, but those are what's known as the Pythagorean identities. Cofunctions. Cofunctions are like shift. So if I take a sine curve and I shift it by pi over 2, then I get a cosine curve. And if I take a cosine curve and I shift it by pi over 2, I get a sine curve. And if I take a tangent and I shift it, I get a cotangent. So again, these are what's called the cofunctions, or a shift. Next one is negative. So if I put in a negative angle measure, I'll actually get a negative sine. If I put in a negative angle measure, I actually just get a positive. That's the one that throws everybody. And if I put in a negative angle measure, I get a negative. So cosine is the only one when you put in a negative angle measure, you actually get the exact same thing. If you want to test that, do the cosine of 30 and then the cosine of negative 30 on a calculator, and you'll actually get the exact same answer. All right. There's three things we're going to do with trig identities. We can evaluate using trigonometric functions. We can actually simplify and verify. And I'll be honest, because we are doing a more e-learning right now, we're going to do more simplify. I know I circled the wrong one there. We're going to do more simplify than we're going to do verify. Verify, and I know everybody in this is going to cringe for a second and may even hit pause. Verify is going to look a lot like a proof. So again, those of you that cringed in geometry can hit pause for a second and maybe go get yourself a drink of water before you come back. We are not doing proofs, but again, when we do verify questions, it will look kind of like a proof. All right, here we go. This question we've done. This question is actually something that's previously done. You're given one of the trig functions and a quadrant. I know it doesn't say quadrant 2, but that is what that is. We are in quadrant 2 because we're in between pi over 2 and pi. So now the sine, so opposite and hypotenuse, I can find the missing side using Pythagorean theorem. So the other 5 trig functions using the angle measure that's between pi over 2 and pi with a sine of 4/5. What do I have left here? Cosecant, secant, and cotangent. So cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. So this is actually an old question. The only thing that's new about this question is they don't tell you the quadrant, they give you an interval, which is the same as telling you a quadrant. All right, simplify. And this is what our test is going to be. Anytime I give you the word simplify, how do I know when I am done? I am done when I have one trig function, one number, or I have a number times a trig function. So how do I know I'm done? I'm down to one trig function, or I'm down to just a number, or I'm down to a number times a trig function. All right, so I'm looking at this. Tangent, pi over 2 over pi. And again, you are going to need to have those identities back on those previous pages kind of memorized. This is a phase shift of pi over 2. So what happens when you do a phase shift of pi over 2? It turns into a cotangent. Well, now I'm still not down to one trig function. Cotangent, though, going back to that page, is equivalent to cosine over sine. Cancels. I get cosine. So how do I know that I'm done? When I simplify, I am down to one trig function. Now, for simplicity purposes, I usually don't use the theta. I use an x. So just understand that most of the way through this now, I'm probably just going to use x. You can use factoring techniques. So this has a secant theta. So I'm going to take out like a greatest common factor. Do this again. I'm going to take out a secant out of both. So I took basically like a GCF. I took a secant x out of both. And again, I'm just using x's because it's easier to write an x than it is to write a theta. Tangent squared x plus 1 is a trig function. Okay, if I went back, okay, and I think some of you may need me to go back, so I will, right? Here, tangent squared, okay, 1 plus tangent squared is equivalent to secant squared. So there you go. So I'm going to change this into secant squared times secant, which gets me secant cubed. That is still one trig function. Okay, secant of x times secant squared of x would make secant cubed x. So again, one trig function, one number, or a number times a trig function. How do I know that I'm done? It's got to be one of those three. Verifying, and again, this is where the sad face comes in. When you have a fundamental identity from the chapter to verify, when verifying the identity, you begin the expression on one side. You're only allowed to look at one side. Use algebra and trigonomic properties to manipulate the expression until you get the other side. So again, I already know what the answer is going to be. It's kind of like a proof, okay, in which they give you what you're trying to prove. So they're going to give you what this answer is supposed to be. So when I'm looking at this question, I already know that the answer is 1. Okay, as I go through this, I already know that side's going to stay as 1. How do I know I'm done? When this side is 1 as well. All right, here we go. Anytime you start off with fractions, okay, my first thing is to change everything. Usually I always try to change things into sine and cosine. So if I see a cosecant, then I rewrite that as 1 over sine. And when I see a cosine or a secant, I write that as 1 over cosine. So again, anytime I see cosine or cosecant, and secant, I change them into cosines and sines. So now, what is sine divided by 1 over sine? Sine. Anytime you divide, you multiply by the reciprocal. So I end up getting sine squared. Cosine times the reciprocal, I get cosine squared. And sine squared plus cosine squared equals 1. So remember, when I told you, when you know you're done, is when you get the left-hand side to equal the right-hand side. This will be nearly impossible for us to test with e-learning. This is a situation in which I have to look at your work to make sure that you show how to get that the left-hand side equals the right-hand side. So I will be honest with you, this is probably not a question you will see on your test, but it is something you should practice, and it is something you will have to do a lot of next year. So here we go. I know that the right-hand side is cotangent x, so I'm going to work on the left-hand side. This is a phase shift. Cosecant x, a phase shift of 90 degrees, is cosine x. Cosecant, remember, every single time I see a cosecant or a secant, I usually change it into sine or cosine. So now, 1 over sine times cosine would be cosine over sine. Cosine divided by sine is cotangent using my Pythagorean identities, and I am done. I was able to make the left-hand side equal the right-hand side. Very similar to a proof in which you already know what the answer is going to be. Again, I already know this is going to equal secant x. But here we go. This looks like a Pythagorean identity, and it is. Tangent squared x plus 1 is secant squared. Remember what I said before. Anytime I see a secant, I usually try to change those into cosine and sine. So secant would be 1 over cosine. Well, one of those cancels, leaving me with 1 over cosine, which is secant. So I made the left-hand side equal the right, and that's how I know I'm done. So I manipulated one side of the equation to equal the other side. You are not allowed to manipulate both sides of the equation at the same time. You're only allowed to work on one side, not both. The homework assignment is out of the book. Again, Ms. Kinsel may turn this into a worksheet, but this is very challenging, and really work on the simplified questions because those are the ones that will be on your test. Not to say that the verified questions are not very good questions. If you have any questions, make sure you talk to us. We'll probably have a Google Meet on this. Good luck and be safe.